All right, what's up, guys? So on the test today, a lot of people are struggling with just rationals, which is the thing that we've covered over the last couple of weeks. Uh, Obviously, these are things that we have to review, but it's also the freshest thing and the thing that we've done the last couple of worksheets on. If you didn't do those worksheets, then I kind of don't know what to tell you. Like, if you haven't put in the work during class or on your own, then of course you're going to struggle with this stuff. You can't always just get away with cramming everything towards the end, okay? But here we are. So I'm going to do a little bit of reviews for rationals. I'm going to cover what the graphs look like. I'm going to cover how to add and how to multiply, okay? These rational functions, add slash subtract slash multiply and divide. I'll also cover one little thing that from before, which is factor by grouping, okay, which was number 5. And then on number 5 as well tomorrow, if you still feel uncomfortable on it, I will provide an alternate question that you can do for 75% max credit, okay? So here we go. Let's start with just graphing rationals. And I just want to, if you have a separate sheet of paper to follow along, that's what I'm going to go off of, okay? So the basic thing is just this function 1 over x, right? This is the parent function. And it looks like this on a graph. And we did a book activity and a worksheet of how this looks like this. But there's two main important things going on. There's a couple of values, well, one value of x, that if I plug in, ignore the warning bell. If I plug in x equals 0, then in my function, that becomes 1 over 0, which anytime you divide by 0, that is undefined, right? It's trying to put 0 into groups, but 0 can't go into anything, right? Well, yeah, everything can go into 0, but 0 can't go into anything. So meaning there's no output for this. There's no possible answer. And as I get closer and closer to 0, that means that the bottom of my fraction gets bigger and bigger, or smaller and smaller, which means my total answer gets bigger and bigger, which means I have this thing called a vertical asymptote. And that happens when the function is equal to 0 on the bottom. That's when the denominator is 0, okay? And so if we go to a slightly more complicated question, something like this, if I say like -6 over x minus 3, well, I can see a couple of things are happening. There's going to be a change in the top, right? I went from 1 to 6, but anytime we multiply a function, that's just the dilation transformation, right? So this -6 is dilating. And also, because it's negative, it is reflecting. Okay. And the only other thing we have to know that's different from our regular parent function 1 over x is that there's a -3 on the bottom now. This -3, which is going to change my vertical asymptote. Okay, and what it changes it by is the value of x I need to make the denominator 0, right? Same logic. The vertical asymptotes happens when the denominator is 0, and so really what I'm trying to figure out is what value of x makes this denominator, x minus 3, equal to 0, right? That's how we find the vertical asymptote. So find vertical asymptote. All right. Well, what I would do to solve this is just add 3 to both sides. And so the value of x that makes my denominator 0 is 3. Which means that's where the vertical asymptote is. And so on a graph, I would find x equals 3, and I draw an asymptote there. And then the only other thing that changed is a dilation and reflection. I'm not really scaling my graphs, so I don't care about the dilation. I don't care. Okay. But the reflection is going to flip me upside down. Okay. So originally, my graph, when the numerator is positive, looks like this one, where I go like this and I go like that. But if I was reflected, that means that all of these flip over themselves. So I'll go up like this and across like that. Okay. So that means that what's going to happen with my total function is I'm going to be flipped upside down. So I'm going to go like this and approach my asymptote vertically. And then same thing over here, approach it like that. Okay. The horizontal asymptote doesn't change because I didn't add or subtract anything on the outside. So there wasn't any shift up or down. And so the vertical or the horizontal asymptote stays the same at x equals 0. Okay. Next up, let's talk about how to add and subtract. Okay. So the trick with all of these, at least the ones on the test, is to factor anything you can. If not, then just find a common denominator between each of your two fractions or your two rational expressions, right? And so if I was trying to solve, let's see, let me come up with a problem real quick. Something like this, where I have like 6x minus 6, and then over the 6x is 2n minus 6, and this one is 2n minus, or plus 5, or something like that. Or not n, sorry, x. 2x and 2x, right? In order to add and subtract, I need to find a common denominator. Okay, that's really the step one. And then a subset of that step is see if one denominator can go into another, right? So if, for example, my equation was something like this, 6x over x plus 3 minus 6 over 2x plus 6, I can check that x plus 3 can actually go into 2x plus 6 if I multiply by 2, right? And so that would make finding my common denominator easier. But in this case, in like the ones on the tests, otherwise we have to just multiply the denominators together. But the only way to do that is to multiply each fraction by the other denominator over itself. Okay. So otherwise, the common denominator is the 2 multiplied. Okay, both two things multiplied. So here's what that means. Let me rewrite my function here. Okay, so sorry if you wrote that down. That was just an example. So I have 6x over 2x minus 6 and minus 6 over 2x plus 5. In order to turn the bottom into a common denominator, I'm just going to turn it into these two things, the two denominators multiplied. Okay, which means I need to multiply the right denominator or right fraction by 2x minus 6 over 2x minus 6. And the left fraction by this denominator over itself, 2x plus 5 over 2x plus 5. Okay. And then to do that, you just multiply it out. Okay, so you're going to distribute whatever's in the top to the top, and then you want to just keep the bottom as the multiplication of the same two fractions. Okay, so when I multiply out the top, here's what I'm going to get. I'm going to get 2x times 6x and 5 times 6x. So that's going to be 12x squared plus 30x. And then on this side, I'm going to get 2x times 6 is 12x, and negative 6 times 6 is minus 36. And I'm subtracting it, right? So I'm subtracting all of this. My denominator is now the same. It's just common. It's just these two things multiplied, right? Which is just 2x plus 5. Oops. 2x plus, let me rewrite, where's my pen? 2x plus 5 times 2x minus 6. Okay, so once again, I just distributed and multiplied the tops by whatever I'm multiplying it by, right? Basically, I have to make the common denominator the same, and the tops also get affected. And then once you're here, because everything's over the same denominator, you just subtract or you just add, okay? Since I'm subtracting this whole thing, really what that's doing, I'm going to distribute this negative. And so basically my next step will be this, 12x squared plus 30x, and then minus 12x, and then I'm subtracting negative 36, so I'm really adding 36 over this common denominator, 2x plus 5 times 2x minus 6. And then the only last step we can do is combine these two like terms. We have two values that have x's in them, and so my final answer will be this, 12x squared plus 18x, that's 30 minus 12, plus 36 over 2x plus 5 times 2x minus 6. Okay, there you go. Nice. I think technically there's one more step you could do to make this smaller, but that's okay. You could factor out a 2 in all the top and bottom, but I'm okay with that. All right, cool. So the tricky part with adding and subtracting is finding the common denominator. If one can go into the other, then just multiply to make that happen. Otherwise, just take each fraction and multiply the other one by the denominator top over bottom. So like I'm taking the right fraction and multiplying it by the left denominator over itself, taking the left fraction and multiplying it by the right denominator over itself. And then you just get something that you might have to simplify a little bit, but there's your final answer. Okay? The only difference between adding and subtracting is this step where I subtracted everything all at once, and so I distributed the minus sign. Otherwise, I would just add these two things together. Okay? Let's talk about multiplying and dividing. Multiply and divide. Okay? And with these ones, the trick is to factor anything you can. All right? And then if there's anything that cancels when I multiply or divide them, just cancel those out. All right? And so if I say, let me pull up a question here. Yeah, this is a good one. All right, so let's divide these two. So let's do k minus 1. I'm going to change all these to x's. X minus 1 over x squared minus 2x plus 1. Hey, that looks similar to something I've seen. And then divided by 6x squared minus 48x over x squared minus 18x plus 80. Okay. So I think this one's actually trickier than the ones that are on your test, but let's break it down. Let's do it. Okay, so the first thing I want to do is factor anything I can. Meaning I want no more x squareds. I just want to write everything in terms of x minus something or x plus something, okay? And so when I look at this thing first, I can notice that this is going to be factorable, right? This quadratic right here, and here's how I would do it. Okay, so I'm going to factor this. Really what I'm trying to figure out is a times c up top, b on the bottom. I need to find two numbers that multiply to, in this case, 1. Okay, that's a times c is just 1. A is just this term, or 1x squared, I guess. And then b is negative 2x. I want to find two numbers that multiply to negative 2, but add to positive 1. Sorry, vice versa. Two numbers that multiply to positive 1, but add to negative 2. Well, the only way to multiply to 1 is 1 and 1, and it just happens to be negative 1 and negative 1 because negative 1 plus negative 1 is negative 2. And so because my leading term, x squared, is just 1x squared, I actually don't have to use the box method if you don't want, because I know that this factors as this, x minus 1 from this times x minus 1 from this, okay? So this whole thing, this bottom, is now this. This is factored out, okay? And so let's take a step to rewrite that. I'm going to do all the other factoring things over here. X minus 1 over x minus 1 times x minus 1. Cool, okay? You might see something that you want to do first, and that is cool. You can cancel something there, but we'll leave that be for a second and cancel in a minute. Now let's factor this one. Okay, so let's factor this right here. Or I guess we can do it off to the side right here. Okay, and what factoring in this case is, this one's a little tricky because there's no C, but really what this means is find something that's in common between each of these. I noticed that there's an X in each of these, right? So that means I can factor that out. I can pull that out. And also 6 can go into both 6 and negative 48. And so I'm going to factor out 6x, all right? And what I'm left with on the inside is whatever I need to multiply to 6x to get back to this. In other words, I'm just dividing both of these by 6x. And so this is x, okay, 6x times x. And then negative 48x, well, 6 divided by negative 48, or negative 48 divided by 6 is negative 8. And so once I factor out that x, those cancel as well. And so really this top is factored like that. Okay, so 6x times x minus 8. Now let's factor this. And we're going to use the same logic as the one on the left, but the numbers are a little bit bigger. And it goes like this. A times c up the top is 80, right? Or I guess 80x squared. But once again, because this leading term is just 1x squared, I actually don't have to factor using the area model, all right? And then on the bottom, it's just negative 18. And so I need to find two numbers that multiply to 80, but add to negative 18. Well, the fastest way I can think to multiply to 80 is 8 and 10, which if I think about it, they do add to 18, but not negative. So if I make both of them negative, then they multiply to a positive, but add to a negative. And so my factor in total is this, x minus 8 from this, and x minus 10 from this. All right, so now that we have everything factored, let's rewrite it. So really, that means divided by my top of the second factor, or the second fraction was 6x times x minus 8, divided by the denominator is x minus 8 times x minus 10. Okay, so now, once we're here, I see some things that are on the top of a fraction that are also on the bottom, which means we can cancel them out, right? In the left one, there's an x minus 1 up top and an x minus 1 on the bottom. Those cancel out. Those are the same at every place. There will be like some technical things like a whole, like if you remember from one of the questions, when you cancel out two factors, that leaves a whole. In this case, I don't really matter. It doesn't matter because I'm just dividing these, not graphing it. And those x minus 8s can cancel as well. And so what I'm left with is this. If I've factored out x minus 1, or if I've canceled out x minus 1 and x minus 1, then really what I'm left with is just what they are divided. And anything divided by itself is just 1. So this becomes 1 on the top times x minus 1 divided by 6x over x minus 10. Okay, cool. Now we're ready to actually combine these two things. And so to remember, once you actually, so I guess I said step 1 was factor. Step 2 is cancel. And then step 3 is to actually do it. Actually multiply or divide. Okay. If you're dividing, you have to remember a simple 4-step process. Number 1 is skip it. Number 2 is flip it. Number 3 is ship it. And number 4 is simp it. Okay. Skip it means don't do anything to the first. Okay, so leave the first fraction. Flip it means rewrite the second fraction as its inverse, as itself upside down, or its reciprocal, right? So really, this becomes x over, or 1 over x minus 1. And then the ship it means multiply. So dividing by a fraction is the same as multiplying by its reciprocal, or the opposite. Okay, itself over, or the two halves flipped over themselves. Okay, and then actually ship it. So that means just multiply this out, meaning multiply top to top, bottom to bottom. So I'm multiplying top to top, bottom to bottom. So this becomes x minus 10, because 1 times x minus 10 is just x minus 10, over x minus 1 times 6x, you just got to distribute this out. And so it becomes 6x squared minus 6x. Okay. And then last but not least is simp it, meaning simplify anything that you can. And what I can notice in this step is that on the bottom, in the denominator, there is a common term. There is something that goes into both of these, and it is 6x. Kind of just like the top of this, our original fraction, the top of it. I know that on the bottom, I can factor out a 6x, and what I'm left with here is x, and then 6x divided by 6x is just -1, or negative 6x. Okay? And that's my final answer. Woo! If you're just multiplying, then you would just multiply it top to top and bottom to bottom. Okay? So the big trick with these is to fraction or factor everything you can, because if you don't, you're going to make yourself really, really have a hard time, because everything is going to be like x to the 4th or x cubed or something, which then is hard to factor, but it's not impossible. And here's why. What a segue to factor by grouping, which is question number 5. Okay. Now with this one, once again, I will give you a safety problem where you can just tell me the things about a graph. I'll give you a already factored problem, and you can tell me those things, and I'll give you 75% credit. So essentially, you're just going to miss the factoring part of that problem. If you want it, though, let's go over how to factor by grouping again. All right. And then let me see if I can do this kind of nicely. Let me see if I can find a nice one. Hold on. Boop. Wait. Wait, let me see. Oh, there we go. Awesome. Okay, got it. So let's do this one. 2x cubed plus, oh wait, that's literally the test question. How crazy is that? Here we go. Let me generate another one. Ah, wait. I can find one. There it is. That's a good one. Okay. Let's do 4x cubed minus 5x squared minus 16x plus 20. Okay. So I did leave this hint on the board, but here's what I mean by factor by grouping, which we did in that packet, by the way, the packet before break. If you have that, then I guarantee you're going to feel okay. So your two groups are the first two terms and the second two terms. And what you're trying to do, this is also on the Jeopardy. Also, what you're trying to do is figure out what's in common between each of your groups. Okay, so what's in common in each? And what I mean by that is, what can multiply into both? What can multiply into both? Okay. And so here's what I mean by that. If I look at my first group, which is 4x cubed minus 5x squared, okay, I notice that both of these have an x squared in them, right? There's a x squared right here, and there's also an x squared hidden within the x cubed, right? In order to get to x cubed, you have to multiply by x squared, right? This is the same thing as x squared times x. And so really what I can do is factor out what's in common, which is x squared. So here's how I do that. I'm going to take x squared, and I'm going to remove it from my set of parentheses. And to find what goes on the inside, I just find what's left over. I'm basically going to divide everything by x squared. Okay. Well, if I divide this out by x squared, I still have the 4, but now I have 4 times x, because x cubed divided by x squared is just x, minus 5 times x squared is just 5, okay? Then, this is as simplified as I can get it because there's nothing that can go into both of these, okay? But x squared I pulled out. Then, for this thing, same logic, negative 16x plus 20. What's in common between here? And in this case, I'm thinking about what can multiply into both. And I can see that I don't have an x that goes into both because this 20 doesn't have an x. But the number 4 can multiply into both. And in fact, the number negative 4 can, which is good because I want to try and get rid of the negative right here. And so what I'm going to do is I'm going to factor out a negative 4. And what I'm left with is whatever is here divided by negative 4. So I'm going to divide this by negative 4 and divide this by negative 4 because I'm factoring it out, right? I'm sort of inverse multiplying, which is just dividing. And so negative 16x divided by negative 4 leaves me with 4x. And then 20 divided by negative 4 is minus 5. Okay. And now my equation is just this thing, right? I've rewritten this top equation into this new statement, which I know I'm on the right track because I notice that this and this are the same, right? I've found a common factor between each of my two groups, and it was 4x minus 5. And here's how I rewrite this, okay? Here's the real factor by grouping step. Here's how to take your final step. Well, almost final. I know that x squared is multiplying 4x minus 5. I also know that negative 4 is multiplying 4x minus 5. So that means that x squared minus 4 is multiplying 4x minus 5. Okay. Which, hey, I've successfully found a common factor, x squared minus 4 times 4x minus 5, that is the same as this thing right here, right? This original top equation, which was a cubic. Now, because I still have an x squared, I can take one more step. I can use difference of squares to factor x squared minus 4. The difference of squares simply means this, and I'm going to do this off to the side. Difference of squares. If you have two square things, two perfect squares, that are subtracted from each other's, two perfect squares subtracted, right? Difference of squares, two perfect squares subtracted. I know that x squared is a perfect square because there's two numbers that multiply to it. It's x times x, right? I know that 4 is a perfect square. It's just 2 times 2, okay? But because I'm taking the difference of them, really this is negative 4, which means one of these things has to be negative 2, which means I'm multiplying x times x and negative 2 times 2, which that process is really just writing it like this. X minus 2 times x plus 2. Because at every step along the way, I'll multiply x times x and I'll multiply negative 2 times 2. What happens with this is that if I were to actually multiply this out and distribute this using FOIL, negative 2x and positive 2x would cancel, meaning there's no middle term. There's no b value, which this one doesn't have. And so really, this is that factored, right? Difference of squares. And that is multiplying 4x minus 5, okay? If you still feel like, okay, I mean, the difference of squares, maybe it looks simple, but I don't understand how it works, that's okay, because here's an alternate. Here's an alternate. If you're at 4x, x squared minus 4, you can actually just factor this in the normal way. You can think about a times c, and you can think about b. A times c in this case is going to be negative 4x squared, right? A and c, but b is nothing. There is no b. There is no blank x term, and so it's just 0. And so in other words, you're trying to find two numbers that multiply to negative 4 but add to 0. Hey, guess what? That's negative 2 and 2, which means your final factor is going to be x minus 2 times x plus 2. Okay? Now, on actual number 5 on the test, once you're here, or the equivalent of that on that problem, you can then tell me the things that this does on a graph, which is in the review packet, right? There was one where it was like had some different multiplicities, but this multiplicities are all 1. And so really all you got to find for me is the degree of this, which if all 3 of these are multiplicity of 1, I bet you could figure that out. You have to find me the y-intercepts, and you have to find me the zeros. Once you have all those things, you can graph it and use the end behavior, or I guess just use the graph to determine the end behavior. Okay. So hopefully you can find some time to take these as notes. You can use them tomorrow if you have them, right? I'm still making it, any notes are open, including your book and including any worksheets you have. So if you're at home right now and you know, I gave back every worksheet I had turned into me. If you didn't turn a worksheet, then I didn't grade it, so I didn't give it back to you. But you might have it almost done, right? Or some of it done, because I did do a lot of the problems. So if you have those, find those. So you can use them as notes, because that'll re-jog your memory, especially over rationals and stuff, which we've done over the past few weeks. Okay. Anyway, thank you guys for watching. Good luck. You can email me if you need anything, but thanks.